Hey everyone, and welcome back for another deep dive. Today, we're tackling a fascinating challenge in AI.
Okay.
It's how to get large language models,
Mm-hmm.
those really powerful AI systems to understand cause and effect.
Yeah.
I mean, we humans do it without even thinking, right?
We do. Yeah. It's fascinating.
But for these LLMs, it's a real head scratcher.
It is. You see, while LLMs can process tons of information super fast,
Right.
they often struggle when it comes to understanding those tricky nuances of causation. It all boils down to that classic problem of correlation versus causation.
Yeah.
We all know that just because two things happen together, it doesn't necessarily mean that one causes the other, right?
Right, like that old joke about ice cream sales and shark attacks both going up in the summer.
Exactly.
Obviously, one doesn't cause the other,
Yeah.
but it's a funny correlation to think about.
It is, and that's precisely where this research paper that we're diving into comes in.
Okay.
It's called Prompting Strategies for Enabling Large Language Models to Infer Causation from Correlation.
Got it. So this research is all about teaching LLMs how to figure out if there's a real causal link, even when all they have is this correlation data.
That's a great way to put it.
It's kind of like being a detective, but only having these statistical clues.
Yes, exactly. The researchers are basically trying to equip LLMs with the ability to do formal causal reasoning,
Okay.
which is actually different from the kind of common sense reasoning that we humans often rely on.
So formal reasoning. That sounds a bit technical.
Yeah.
What's the difference between formal reasoning and common sense reasoning?
Well, think of formal reasoning as a very structured, rule-based approach.
Okay.
It's like using a specific algorithm, like the PC algorithm, to analyze the relationships between variables.
Mhm.
And what's cool about it is that it works no matter what those variables actually represent.
Okay.
It's pure logic, just based on the data itself.
So it wouldn't matter if we're talking about ice cream or sharks or something totally random.
Right.
It's all about just following the rules.
Right. Exactly. Precisely. On the other hand, common sense reasoning relies more on, our existing knowledge about the world.
Right.
It's like we just know that people use umbrellas when it rains. Right?
Yeah.
You don't need some fancy algorithm to figure that out.
Exactly, right.
Yeah.
But LLMs don't have that kind of real-world experience, so we need to teach them to think more formally.
Yeah, exactly right. And to test how well LLMs are doing with this formal causal reasoning, researchers have developed this thing called the COR-R2CEO's benchmark.
Interesting. So how does this benchmark actually work? Is it like a pop quiz for LLMs?
Yeah, you could think of it that way. It's more like a series of logic puzzles.
Okay.
Each puzzle gives the LLM some correlation data. For example, let's say A is correlated with B and B is correlated with C.
Okay.
Then the LLM is asked a question like, does A directly cause C?
Got it.
And then there's an answer key that basically tells us whether the causal claim is valid or not based on those given correlations.
So the LLM has to look at the correlations and decide if the cause and effect relationship makes sense.
Exactly. And what makes this research important is that it's not just about solving these puzzles.
Yeah.
It's about seeing if LLMs can really understand those fundamental principles of formal reasoning,
Right.
which is considered a crucial step toward building more sophisticated AI.
So how do we actually help these LLMs do well on this COR2CO test?
Well, the researchers in this paper have come up with a clever prompting strategy.
Okay.
It's called PC-SUBQ,
Okay.
and it's really helped to improve how well the LLMs perform on the benchmark.
PC-SUBQ. I like the sound of that. So what is it and how does it work?
Well, it's actually inspired by the PC algorithm itself.
Oh, okay.
The basic idea is to break down that complex reasoning task into smaller, more manageable sub-questions
Okay.
that actually mirror the steps of the PC algorithm.
Got it.
It's kind of like providing a step-by-step guide for the LLM to follow.
Okay, so it's like breaking a big problem down into
Right.
smaller, easier to understand chunks.
Yeah, exactly. And then to further help the LLMs, the researchers used a technique called few-shot chain of thought prompting.
Okay.
So basically, they gave the LLMs a few examples that were already worked out, showing them the reasoning steps involved.
So like giving them some training wheels to help them learn.
Yeah, precisely. And the results were pretty impressive.
Oh, cool.
They tested PC-SUBQ on 5 different LLMs, and across the board, they saw significant improvement.
Wow.
One LLM, called PaulM2,
Yeah.
even had a huge jump in its F1 score, which is a way to measure accuracy.
Okay, yeah, that's really impressive.
Yeah.
So this PC-SUBQ strategy sounds like it could be a game changer for helping LLMs understand cause and effect. But is it just a one-trick pony? Something that only works on this specific benchmark?
Well, that's one of the exciting things about this research, actually.
Oh.
The researchers found that PC-SUBQ is surprisingly robust,
Okay.
and it can actually be applied to lots of different situations.
Interesting.
So it's not just about the LLMs memorizing patterns. It seems like they're actually learning some real underlying logic.
That's really cool.
For example, the strategy still worked really well, even when the researchers changed the names of the variables in the puzzles.
Okay.
Like they swapped A and B for X and Y,
Right.
and it didn't confuse the LLMs at all.
That's interesting. So it's like they're not just learning to associate specific words.
Right.
They're understanding the relationships between those concepts.
Precisely. And it gets even better.
Oh, wow.
They also found that PC-SUBQ was still effective,
Yeah.
even when they rephrased the causal relationships.
Wait.
So instead of saying A causes B, they might say B is affected by A, but the LLMs still understood what was going on.
Wow. So it's like they're moving beyond just matching words to actually understanding those deeper concepts.
Exactly. And to really push it to the limit. They even tried PC-SUBQ on examples using real-world scenarios.
Oh, cool.
Like that ice cream and swimming pool example we were talking about before. And even in those more complex situations, PC-SUBQ still performed really well.
So it sounds like PC-SUBQ is a pretty powerful tool to help LLMs get better at causal reasoning.
It is.
But I'm guessing there are still some limitations, right?
You're absolutely right. No strategy is perfect.
Yeah.
And PC-SUBQ does have a couple weaknesses.
Okay.
One of the main ones is that its performance tends to drop when you increase the number of variables in the problem.
That makes sense.
Right.
Because the more variables you have,
Right.
the more complex the relationships are.
Exactly.
And it's just harder to sort of untangle those causal links.
Exactly. And another limitation is that PC-SUBQ can be a bit slower than some other prompting strategies because it breaks the problem down into all these multiple steps.
Yeah.
It takes a bit longer for the LLM to come up with an answer.
So it's like taking the scenic route instead of the highway.
That's a great way to put it.
You get a more complete view, but it takes a little longer to get there.
Yeah, exactly. But despite those limitations, PC-SUBQ is a significant step forward for AI research.
Okay.
It's opening up some really cool possibilities for developing even more sophisticated and robust approaches to causal reasoning in LLMs.
This has been really insightful. I'm curious to hear more about what's next for this research. Where do we go from here?
Well, one promising avenue is to develop even more diverse benchmarks that include a wider range of those real-world scenarios.
Got it.
You know, think about testing LLMs on causal puzzles based on historical events, scientific discoveries, or even social trends.
So it's like taking those AI detectives from textbook cases to real-world mystery.
Yeah, exactly. And another interesting area of research is to explore ways to combine PC-SUBQ's formal reasoning capabilities with that common sense knowledge that LLMs are already pretty good at.
Right.
So by blending those two approaches, we could potentially create even more powerful AI systems that are capable of understanding cause and effect in a much more nuanced way.
It's like taking AI from just crunching numbers to actually being able to really understand the world.
Precisely. And that's why this research is so important.
Yeah.
It's not just about making AI smarter. It's about creating AI that can actually help us better understand our world and our place in it.
Well said. It seems like we've only just scratched the surface of what's possible with AI and causal reasoning. And with that, we're going to take a short break.
Okay.
But don't go anywhere, because when we come back, we'll continue our deep dive into the fascinating world of AI and its quest to understand cause and effect. We'll be right back.
Sounds good. Welcome back to our deep dive into AI's journey to mastering cause and effect.
Okay, so before the break, we were talking about how this PC-SUBQ strategy is helping LLMs grasp formal causal reasoning, specifically mimicking the PC algorithm.
Yeah.
But you also mentioned that the PC algorithm itself has some limitations.
It does. It's very powerful, but the PC algorithm operates under a pretty big assumption.
Okay.
It assumes we have all the relevant information, that there's nothing hidden messing with the data.
Ah, okay. I see where you're going with this. What kind of hidden factors are we talking about?
Well, in the world of causal inference,
Okay.
these hidden gremlins are called confounders.
Confounders. Okay.
There are like secret connections between variables that can really throw off our analysis.
Okay, can you give me an example?
Sure.
I'm having a little trouble picturing this.
Imagine you're trying to figure out if there's a link between drinking coffee and heart disease.
Okay.
You find a correlation, but there's a hidden confounder, stress.
Okay.
Maybe people who are stressed drink more coffee and are also more prone to heart problems.
Right.
So it might not be the coffee itself that's causing the issue.
So it's like a third variable.
Yeah.
That's secretly influencing both the supposed cause and effect.
Exactly.
Making it look like there's a direct link when there really might not be.
Precisely. And the PC algorithm, in its classic form, isn't really designed to handle these confounders very well.
So if we're training LLMs based on this algorithm, wouldn't they inherit this weakness?
That's a really good observation, and it's definitely a challenge that researchers are trying to figure out.
Okay.
But that's also what makes this research so exciting.
Yeah.
It's pushing us to think beyond the limits of what we can do now.
So what are some of the ways researchers are trying to overcome this confounder conundrum?
Well, one promising path is to develop more advanced algorithms.
Okay.
That can actually detect and account for these hidden factors.
Got it.
There's a whole field of causal inference that's dedicated to tackling this problem.
So it's like giving our AI detectives better tools to uncover those sneaky connections.
Exactly. Another interesting approach is to use all of that data that LLMs are trained on.
Okay.
Think about it. Even though they haven't lived like humans, they've processed so much text and code.
Right.
Maybe there's a way to use that knowledge to help them make better judgments about cause and effect, even when those confounders are present.
It's like they've read every detective novel and every scientific paper.
Yeah.
Maybe there are clues in that data that could help them identify the confounders.
That's the idea. It's about finding ways to use that hidden knowledge and turn it into a deeper understanding of those causal relationships.
This all sounds pretty theoretical. Can you give me some real-world examples?
Sure.
Like, how could LLMs with better causal reasoning skills actually be used?
Well, imagine using LLMs to analyze medical data, to figure out potential side effects of new drugs, or to predict which patients might respond better to certain treatments.
That could really change healthcare.
Right.
It's like having an AI doctor.
Yeah.
They can go through all that data and find the best treatment for each patient.
Exactly. Or think about using LLMs to study climate change.
Okay.
They could help us understand all those factors that are contributing to global warming and figure out the best ways to stop it.
That's a challenge.
Yeah.
We really need this kind of analysis for.
Yeah.
AI could help us see the bigger picture.
Right.
And make more informed decisions.
Exactly. And it's not just about solving these big global issues.
Yeah.
LLMs with strong causal reasoning could also help us make better everyday decisions.
Okay. Like what?
Imagine an AI assistant that helps you choose the best route to work.
Okay.
Based on traffic, weather, even your own personal preferences.
That would be pretty awesome.
Right.
It's like having a personalized navigator for your life.
Exactly. But as we give AI this deeper understanding of cause and effect, we also need to think about what that means.
Yeah. What are you thinking about?
As their abilities grow, so does the need to develop and use them responsibly.
You're right. We need to make sure these powerful tools are used for good.
Exactly.
And don't create more problems than they solve.
That's why it's crucial to get lots of different people involved.
Okay.
In developing and governing AI. We need ethicists, social scientists, policymakers, working with engineers and data scientists to make sure these technologies benefit everyone.
It's like building a team of superheroes with different powers to make sure AI is used for good.
I like that analogy. It shows how important collaboration is.
Right.
This isn't just a technical challenge, it's a societal one.
Absolutely.
Yeah.
So where do we go from here? What are the next steps on this journey of AI and causal reasoning?
One key area is to keep developing ways to evaluate AI's causal reasoning abilities.
Okay.
We need to be able to measure their progress, see where they're struggling, and make sure they really understand cause and effect, not just copying patterns.
So, like, we need to come up with a good way to test them and make sure they're learning the right stuff.
Exactly. Another important step is to have open conversations about what AI could mean for us.
Okay.
Both the good and the bad.
Right.
We need to talk about it at all levels of society.
Yeah. To make sure AI is used ethically and responsibly.
It's like we need to have a global town hall meeting.
Yeah.
To decide the future of AI.
Exactly. The future of AI isn't set in stone.
Yeah.
It's something we're all creating together.
Right.
And if we work together, we can make sure AI benefits everyone.
This has been really thought-provoking. I'm definitely even more fascinated by the potential of AI and what it could do with causal reasoning. But for now, I think we need to take another short break.
Sounds good.
And we're back, ready to wrap up our exploration of AI and causal reasoning.
Yeah, it's been quite a journey.
It really has. You know, as we've been talking about all of these advancements, I can't help but think about all the philosophical questions that come up when we give AI this deeper understanding of cause and effect.
It's true, you know. It's one thing to build machines that can just process data and make predictions.
Right.
But when they start understanding the why behind things, it really does bring up some big questions.
Like what? Can you give me an example? Well, think about the idea of responsibility.
Yeah.
If an AI system makes a decision based on its understanding of cause and effect, who's to blame if something goes wrong?
That's a good question. Is it the AI? The people who made it? The people who are using it?
Those are the tough questions.
Yeah.
And it makes you wonder if we're successful in creating AI that truly gets cause and effect.
Yeah.
How will that change our relationship with technology?
It's a fascinating question. Will we see these AI systems as partners?
Right.
Collaborators?
Yeah.
Or even competitors?
Exactly. And how do we make sure that they share our values and goals?
Right. It's almost like we're entering this whole new era of human-machine interaction where the lines between creator and creation are getting blurry.
Yeah, I think you're right. And as we figure out this new territory, it's super important to move forward carefully, but also with excitement.
Right.
We need to embrace what AI can do, but also be aware of the possible risks.
It's a tough balancing act.
It is.
But I'm optimistic that if we work together, we can use AI for good and create a future where both humans and machines thrive.
I agree. I think AI has the potential to be one of the most transformative technologies ever, but it's up to us to make sure it's used ethically and for the right reasons.
Well said. So as we wrap up our deep dive into AI and causal reasoning, any final thoughts for our listeners?
I'd say stay curious, stay engaged, and keep talking about AI. This technology is changing so quickly.
Yeah.
And it's going to affect all of us.
That's true.
By learning about it and having those important conversations, we can help shape a future where AI is a force for good.
Great advice. Thanks for being here today and sharing your expertise.
Of course, it was my pleasure.
It's been a really enlightening conversation.
Yeah, it's always fun to talk about these topics.
And to our listeners, thank you for joining us on this deep dive into the world of AI and causal reasoning. We hope you learned something new and that it got you thinking. Until next time, keep exploring, keep learning, and keep those questions coming.
See you next time.